Hello, I'm Jeremy Balmer, and this is my video presentation to go along with my supervised machine learning final. The first question was to take some eBay data about 1,972 auctions that took place on eBay between May and June 2004. The data had a classification of whether the auction was competitive or not. Using this data, the task was to try and predict whether an auction would be competitive or not based on the other variables that was included with the data. The first step was to pull the data in, and I just took a quick look at it, did a little bit of cleanup, setting the duration as a factor, and pulling the period off of the competitive value. Next, I created the training and validation sets and ran a random forest model on it. Originally, I tried to run the trees model, but it did not work out too well, only having the competitive with the two leaves for 0, 1 below it. After that, I switched over to random forest and got much better data. The out of bag air chart showing a steady decline from 4 to 15. After 15, it kind of tapers off, showing that 15's the best try. And if you go further, just really isn't that much of an advantage of going further. After that, ran the random forest model on the data, and after plotting it, it was pretty quickly clear that open price and close price were the two variables that had the most importance to predicting whether an auction was going to be competitive or not. So the final step here was we had two really good predictors, but can we trust a model? And for that, ran a confusion matrix to see if the accuracy was here. And all in all, the model is pretty accurate. The p value is pretty close to zero, proving that statistically significant, and with an accuracy of roughly 89%, this is a good model. The next question is about Takeo Software. They are a software company that sells games and educational software, and they're looking to use some information from prior mailings and see if they can look at that and see if any of the variables will help indicate higher spending. So the first step was to bring in the data and then do a little bit of cleanup. There was a bunch of columns on there that weren't needed, so we only selected the variables that were needed for this analysis. After that, I just did some renaming to try and standardize how that data was coming across. And I replaced the zeros and ones with text fields to just make it generally easier reading. Next, I created a pivot table just to get a grasp of how everything was sitting. It had the average spending and standard deviation of spending based on categorical value. The ones that really stuck out here were if the address was not the residence, there seemed to be a bit of a spike. The gender is a female, there's a bit of a spike. And if it was a web order, it was also a bit of a spike. Next, I applied two scatter plots with trend lines. There was a linear line in red and a smooth line in purple. The spend inverse last update in days really didn't show much of a relationship, a little bit downwards, but the spend inverse frequency showed a very strong positive relationship. Next, I tried to fit a predictive model for spending. I started by partitioning the records and then ran a linear regression model on it. After running the model, I validated the results, checking against the training set against the validation set. And then I ran a neural network model. This is the point I realized that I really shouldn't have mutated the columns for those different variables from binary of 0, 1 over to characters. So switched that all back and then drove forward. After running the model, I looked at predicted versus actual spending in the training data set, and it was severely underfitting the model. When I compared this against the validation set, I got the same results. When looking at both models, the neural network model performed very poorly and was severely underfitting. The RSME values also showed that the linear regression model performed better.